Okay, so I'm happy to revisit Drawdown Coming Attractions after many months of recording the original course. In each course, I try to upgrade the content based on the new research, new material that I find. So under Coming Attractions, I decided to add three podcasts. One is on whales as nature-based services and elephants as a nature-based service as well. We talk about ecosystem service, their value and so on, and yet we have situations where deforestation happens. People like forests, but they are not sure how much it is worth or how much they are willing to pay. Whales, people go to watch whales, but they are not sure often what the whales are even doing in terms of their role in being a part of the natural ecosystem, carbon drawdown, biodiversity, and so on and so forth. So it's worth running through these from some beautiful infographics and papers that we can find. So this is a nice image of a whale, which I should know which one it is, but maybe it's a blue whale. So typically there are many species of whales. The biggest one is of course the blue whale, which travels all the way across the equator to the Southern Ocean to feed on krill, and that's the one that has been always used as an example of ecosystem services provided by the whales. To look at some of the numbers, obviously you are aware that whales are being hammered pretty badly by traditional whaling. There have been communities which have lived on whaling up in the Arctic Circle, for example, and they have remained steady over time. You can see here. So they hunt, let's say, less than about 400 whales per year here, going from, this is only for 2005, 6 to 16. So 15, 16 and 16, 17. So the total number of whales that have been killed by humans by year has come down a little compared to, let's say, 2005, 2006, but the numbers are still fairly high. So there is traditional whaling, commercial whaling, and whaling for scientific purposes. There are claims of cultural value and cultural practices by Japanese and Norwegian whalers who do not want to give it up, but that's what human beings always do. Just because something is good for nature doesn't mean we're going to stop perturbing that system, right? Arguments are made that whale is an international public good. Why? We'll see a few infographics to see how that conclusion can be made, and in the end we will also try to put some monetary value on the services by whales, and the numbers are pretty astounding. The question then is, can we really translate that into making people pay for the whale services? Okay, so here are the summer feeding grounds in blue. You can see it's in both hemispheres, very heavy in the Southern Ocean, all the way into the Arctic here. Winter breeding grounds are closer to the lower latitudes, so mid-latitudes to the tropics. And probable resident population, there have been evidences now, or sightings of whales in the Arabian Sea. I'm not sure of in Bay of Bengal. So there is indirect evidence that maybe there is probable resident population in these as well. So here, of course, seasons are for the respective hemispheres. Whales killed throughout the Southern Ocean to near extinction during the 20th century. You can see the numbers, they're pretty astounding. 725,000 fin whales, 400,000 sperm whales, 360,000 blue whales, 200,000 sei whales, 200,000 humpback whales, so a total of more than 2 million which is not good news considering their numbers now going down. Such massive mammals over time have been a big part of the ecosystem and so-called ecosystem services. So I will run through several such schematics. This one is from Grid Arsenal. So whale carbon and oxygen flux. They are moving nutrients, carbon, waste products, which are a very rich source of iron, for example, which is a very valuable micronutrient in the ocean. A lot of phytoplankton and upper level species like krill depend on iron for their survival and life cycle. Oxygen flux is always critical. So here, schematically speaking, phytoplankton take up atmospheric carbon and release oxygen. Whale pump works in a way where all whales dive underwater to feed and return to the surface to breathe. At the surface, they release buoyant fecal plumes that are rich in nutrients that phytoplankton need to grow. So usually the ocean circulation and mixing tend to bring up the nutrients. So the nutrients that are used by the phytoplankton for photosynthesis sink as the phytoplankton die or grazed and converted into fecal pellets by other species, and that nutrient has to be reformed from organic matter into nutrients like nitrate, iron, phosphorus, and so on, and brought back to the surface. So the biological pump is usually this movement of nutrients by living things, and there is a solubility pump which is related to circulation, upwelling, and mixing. So here the whale pump is diving down and coming back up and eating, of course, wherever it finds food, and come back and produce these so-called fecal plumes or fecal pellets and big blobs, which are full of nutrients that are recycled or remineralized into the water where the phytoplankton need it. So phytoplankton need light and nutrients, obviously. Then the feeding grounds movements also bring breeding ground. From feeding grounds to breeding grounds also there is migration and movement of nutrients and so on. There is a great conveyor belt of whales, just like the conveyor belt in the circulation that we talk about, deep water sinking, circulating through the bottom of the ocean, getting converted to the surface water and coming back to the formation sites of deep water in the North Atlantic, Ross Sea, Weddell Sea, and so on. So many whales migrate from nutrient-rich feeding grounds to nutrient-poor breeding grounds. There are specific reasons why they pick breeding grounds, because they want the young to survive and not be eaten by other predators, for example. On the breeding grounds, whales release nitrogen-rich urea that can stimulate phytoplankton growth. So the nursing calves need phytoplankton, which generate krill, and they can feed on the krill, which is highly nutritious compared to the upper trophic level food that the adults eat. Biomass carbon. All living things are made of carbon and thus serve as a carbon reservoirs throughout their lifespans. The larger and more long-lived the animal, the more carbon is stored. So this is obvious, but even as the whales die and fall to the ground, to the bottom of the ocean, they are taking down massive amounts of carbon with them that then gets sequestered. And there are beautiful videos on YouTube of how a dead whale that falls to the ground is fed on by lots of weird looking creatures at the bottom, because this is a massive amount of meat that is coming down. Okay, that video is really worth looking at. You should dig it up and look at it. Okay, deadfall carbon. When large marine vertebrates die, their carcasses sink to the seafloor. Therefore, the carbon inside their carcass can support deep sea ecosystems and be incorporated into marine sediments. Okay, this is another way to look at it. Here are the marine mammals moving up and down. Whale pump again. Feces and urea being moved up to produce nutrients needed for phytoplankton. ammonium and feces and migration and death, bringing down the carbon and organic matter. So that's the biological pump. So the biological pump is bringing down matter that is grazed and eaten and converted back to nutrients, and carbon is sequestered, and the whale pump can bring it up. Okay, so this is the base of the euphoric zone, where you have enough light for photosynthesis if nutrients are available. How whales sustain life on Earth and fight climate change. This is a slightly different way of looking at it. Here is whales feeding at depth. Whales come to the surface to breathe. As they travel up to take a breath, they circulate nutrients, the whale pump that we already talked about. When at the surface, whales do gigantic poos. So these release nutrients that phytoplankton, tiny plant-like organisms, need to survive. Through photosynthesis, phytoplankton absorb nearly a third of human-generated carbon dioxide from the atmosphere. Phytoplankton provide every other breath you take. The whale pump process creates a thriving ocean habitat. Okay, here are the numbers on them. When a whale dies, their carcass sinks to the ocean floor, called the whale fall. Rebuilding whale population would lead to 145,000 tons of climate-harming carbon being locked away inside whale carcass every year. So if you didn't enjoy watching whales and admiring their amazing beauty, you can at least admire them for being able to take down so much carbon out of the system. This is equivalent to the weight of 16 Eiffel Towers. Approximately 41,000 female African elephants, that's the weight of 145,000 tons of carbon. Approximately 21,000 Tyrannosaurus rex, so you can excite children with these kinds of numbers. Thirdly, the whale carcasses store the carbon for thousands of years. This process prevents the carbon from being released back into the atmosphere, helping to combat climate change. Whale carcasses also provide food and a home for up to 200 species at the bottom. Again, please go and look at that YouTube video. That's so beautiful. This is a nice review of or a news and views article by Victor Smedacek, who was, I think, one of the first ones to suggest that whale poop was a big part of the iron cycling in the Southern Ocean. He's writing this on an article that's published in this journal Nature, in this issue very recently, about how much the whales actually feed. So blue whale, for example, is feeding on krill. It's like humans eating ants. Blue whale is the largest animal on the planet, and it's eating these tiny krills. Why? Because they are nutritious, and they come here typically to nurse their calves. So they do iron dispersal. Iron-rich whale feces, whale plumes that you can see are releasing iron for diatom blooms, which is a phytoplankton, which is eaten by krill, and producing iron-rich krill feces as well. So if whales are eating krill, you think if whales are reduced in number, the krill number would go up. But actually, that doesn't happen, because actually whales themselves are an important part of helping diatom blooms and then producing food for the krill. So you can see what a nice symbiotic ecosystem that is. So what the paper says is that whales eat up to 3 times more prey than was previously thought. Up to 3 times. This is a big massive animal that's the size of several school buses, and it just opens its mouth and swallows millions of gallons of water, and then just takes all the krill in. A system of iron cycling might help to make such a high level of feeding sustainable, so it's producing its own food by making this loop possible, and could explain why krill stocks fell when whale numbers declined as a result of whaling. Iron availability limits productivity in ocean waters, and when whales eat iron-rich prey such as krill, they convert prey protein into blubber and aid iron cycling by defecating the iron-rich prey remains. Whale feces might provide a source of iron for phytoplankton such as diatoms and drive diatom blooms. Diatoms in turn can move iron along the food chain when they are eaten by krill, which also excrete iron in their feces. Diatoms also have silica shells, and they can sink to the bottom and are a major part of the export of carbon by these photosynthetic animals as well. Okay, this is from a nice paper in Frontiers on Ecology of the Environment, where ecology and environment, I suspect, where Victor Smetacek was also a co-author. Just to look quickly at the ecosystem services provided by the whales: enhanced primary productivity, enhanced biodiversity and evolutionary potential, climate regulation, culture and conservation, tourism, and provisioning. So whale pump delivers limiting nutrients like iron and nitrogen to ocean surface. Migrating whales bring nutrients in urine, carcasses, and placentas, and so on, that we already talked about. For culture and conservation, whales were among the first marine species to be protected by national and international laws establishing precedents for ocean and endangered species legislation. Whales are valued for their cultural importance and distinctive features such as whale songs. Stranding and fisheries disentanglement responses promote stewardship and concern for the marine environment at large. Research and management programs provide seasonal industries in many communities. Conflict over whaling has promoted a culture of protest and defiance by entities such as Greenpeace and Sea Shepherd. Okay, whale watching is a global industry valued at $2 billion US, and aboriginal and commercial whalings are obviously part of the provisioning. How much is one whale worth? Fishing industry estimated at over 150 billion. Whales contribute to the food web chain and increase fish stocks. Phytoplankton productivity, which is enhanced by whales, captures 37 billion tons of CO2 per year. Whale watching industry estimated at over 2 billion globally, as we said. Each whale sequesters 33 tons of CO2 on average when it dives and sinks to the ocean floor, as we said before. So do you really need more reasons why we need to protect whales and use them for what they are really so good at and so very valuable for? Ecosystem services, biodiversity, cultural value, ecotourism, and natural climate solution, nature-based climate solution. So please take your time, learn more about whales, and do all you can to protect whales and let them grow in number, and let that be a coming attraction. I'm putting this in coming attraction because I'm hoping that the next generation, the generation that is now protesting so strongly at COP26 in Glasgow, will pay attention to these issues, as well as along with all the fossil fuel issues they are so worried about, because that's the most prominent one. But these are also what we are affecting so seriously in a negative way.